Okay, in today's video, we are going to talk about uptime, availability, reliability. So, people often confuse all these terms as similar terms, but they are not. And today, we are going to take a look at what they are, what's the difference, how they are calculated. So, if you see this particular screenshot, when I was starting out my journey and when I saw S3, which is a cloud service object based storage for AWS, they said their availability is 99.99%, which is 4 nines. And I'm like, okay, 52 minutes downtime per year, it's like a lot of effort, right? And then they said the durability is 11 nines. And I was blown away. Like, how can even someone, achieve that kind of durability and availability? But I slowly read what they do in the backend, how they replicate their data, what does fault domains, fault tolerance, how do they replicate the servers in various regions, across regions, right? So that's how they ensure it. So in this video, we're not going to dive into how they do it, but first of all, we will dive into what they basically are, right? So let's start from here. So basically, you can think about uptime as the amount of time that a system is available to users. So think of a server, right, which is continuously on, right? So that means uptime. So it's measured in days. So basically, you can say a server is up for 30 days or a month. The next is availability, and this is where things start to become a little bit different, because availability means, okay, the system is there and it's also working as expected, right? So basically, there's a server, and suppose there's nginx running, serving a page, right? So when a user clicks something, that page is open, right? So that is availability, right? So you can say that when the page doesn't open, the availability of that particular server will be lost, but it is still up, right? Because the server is up, right? So that's the primary difference between uptime. So uptime is, it's just operational, and availability means it is operational and working as expected. So that's the major difference between the two. And then comes reliability, right? And reliability basically means a system is performing its function consistently without failure over a period of time, right? So basically, something can be available, but it can break down in between, and then you need to do some kind of repair or troubleshooting to make it up again. So reliability is a measure where you determine how reliable a system is. I'll show you how we measure it, but basically the keyword here is how consistently a system runs without failure, right? So if I have to define this with an example, let's take a car. So availability of car can be that the car is there, and you go into the car, you start it, it starts, right? So that's availability. Now reliability means when you run that car, how smoothly or consistently it runs without breakdown. So suppose it breaks down 3 times in a year, right? So its reliability will be reduced a little bit, right? And suppose there's another car which breaks down 10 times a year. That car's reliability is even way lesser than the car which breaks down 3 times a year, right? So I hope the difference is clear, but if not, then it will be clear when I explain, the formulas with which we calculate it. So let's come to how availability is calculated. So basically, availability is calculated by total uptime divided by total time into 100. So as I mentioned, uptime is measured in days or month, right? So I will just write it down, measured in days/month. And availability basically is, the percentage of that particular uptime, right? And then reliability is measured using, there are various terms like mean time to repair and mean time before failure. So I'll explain what these terms are, but yeah, these are the units, right? So suppose the server is up 30 days, so we'll say, okay, its uptime is 30 days or a month. So that's how it is measured. But availability is measured in terms of percentage, right? And these are the various availability. So if we say that a particular cloud service, the SLA or service level agreement, is 99%, but let me know if you want another video to describe what are SLAs, SLO, SLIs, which are very common terms in the SRE or DevOps world. But if I say 99% availability, so that means that particular service can expect a downtime of 3 days, 15 hours, right? And if I say it has 99.99% availability, it can expect a downtime of 52 minutes. Now, the difference between 99 and 99.99, it's very less, right? But see the amount of unavailability that is there between them, so it's huge. And believe it or not, the amount of engineering that goes in the back end to make sure that they increase this 0.99, it's a massive chunk of money, it's a massive chunk of engineering that goes in the backend to make a service 0.99% reliable, right? If you have to increase one more nine, the downtime reduces drastically. From 52 minutes, it comes down to 5 minutes, right? And again, it might seem like a very small percentage that you are adding here, right? But it's a lot of effort to go from 99.99 to 99.999 percentage. Now, there's a very good website. If you go to uptime.is, you can just enter the availability here. And suppose 99.99 means daily 1 minute downtime and yearly 8 hours of downtime, right? So if I just do 99.99, you can see that it means daily 8 seconds of downtime and yearly 52 minutes of downtime. And similarly, if I just increase two more nine, you can see that yearly 6 nines means 31 seconds of yearly downtime, which is it's like a magic, right? It's very hard to achieve 6 nines. That's one example, or that's a website where you can measure how much a percentage availability boils down to in terms of seconds or hours. And if you go to any cloud service, there will be some kind of service level agreements there. And here you can see that, okay, for compute engine, the nines are 3 nines, right? And if you have to compute it, it means that hourly, it boils down to 8 hours of downtime, right? Now, there are various ways you can engineer your applications to make sure that even though they are using compute engine, you can increase this particular availability, right? And let me show you how. So basically what you can do is you can replicate your compute engine in two zones, right? Or in two regions. So that way your availability will be increased to 99.9999, which is 6 nines. And what's the formula for measuring the availability when two or more services are involved? So this is the formula. Effective availability will be maximum availability minus 100% minus available dependency into 100% minus available dependency, right? So this will be 100 minus 99.99%, which is 0.1%, and then again into 100% minus 99.999%, which is 0.1%. So if you do this calculation, it will be 99.49, right? And another shorthand is just combine the number of nines. So if a service has 3 nines and you are combining them, if they all have 9 in their availability, you just add the number of nines. So it will be 6 nines. So for example, if there's another service, right? Let's not take example of compute engine now. Let's say there's another service whose availability is just 99%. So now the availability will be just will be 99.99%, right? And if you do this calculation here, so you'll find that that's what it is coming to. So basically this thing, right? So yeah, hope this makes sense. And if there are multiple services, you just calculate this and then keep on adding or multiplying your that particular service over here, right? So suppose there's another service which you have added in your backend or into your infrastructure, then you can do something like this. And suppose that is also 99% available, then the availability will come to this. I hope this makes sense. This is how we calculate the availability of the various systems. So that's about availability. Let's now talk about reliability, right? Now, reliability is measured, or these are the common metrics that we target to measure in terms of reliability, which is mean time between failures, which is the average time between system failures, right? A higher MTBF, or mean time between failures, indicates greater reliability, right? Which is measured by total uptime divided by number of failures. I'll show that using an example, but this is how we calculate mean time between failures. Then failure rate is frequency with which a system fails, right? And then mean time to repair means how quickly you can restore a system, and that is measured by total downtime divided by number of failures, right? And a lower mean time to repair means faster recovery and less downtime. So now let's bring all this together with an example. Let's say you are analyzing the reliability of a web server over a 1 year period of time, which is 8760 hours, right? 24 hours into 365 days. So total uptime of that particular service is 8730 hours, downtime is 30 hours, and number of failures in a year is 3 hours, right? So how you can calculate all these things is the mean time between failure can be calculated by total uptime divided by number of failures, right? So which is 8730 divided by 3 failures, which is 2910 hours per failure. So basically a system runs 4 months before it fails, right? That's MTBF, or mean time before failure. Then the failure rate is here, number of failure is 3, then it will be 3 failures divided by total hours, right? In a 1 year period time, which is 0.00034 failures per hour. And then mean time to repair, that is measured by the total downtime divided by number of failure, which is 10 hours per failure. So it takes 10 hours to restore that particular web service. Now you can calculate availability as well from here, and if you look at the formula of availability, it is total uptime divided by total time into 100, right? So if you do that, what you'll find out is, if I just calculate availability here, availability equals to 8730 divided by 8760 into 100, right? So this will come close to 99.6%, right? So that's the availability of this particular web service. So I hope this is clear, how to calculate reliability, what it is, and how to calculate availability. Now let's move to answering some of the questions. Can we achieve 100% availability, and should we even shoot for that 100% availability? In theory, you can achieve that, but in practice it's very hard to achieve 100% availability, because natural disasters can happen. That's not in our control, right? There can be some fire, there can be some floods, etc. So that's not in our control. No matter how much you replicate something, there's always a possibility that something can go down at a certain period of time. So you can in theory achieve 100% availability, but I would not recommend you to shoot for 100% availability, because if you ask any engineer or any DevOps engineer or SRE folk, you will find out that most of the downtimes happen because of a new feature being pushed or system upgrades, etc. So you don't want to limit the amount of innovation that you do, right? So if you are targeting for 100% availability, then you will not deploy as often as you want, right? Because you'll always be afraid of achieving that 100% availability, and you will be like, okay, no, my system can be down. And that's not a good idea, because then you'll be innovating less, you'll be pushing less, which in the grand scheme of things or in the long term will not benefit your customers. The user satisfaction will not be there, right? So you have to balance the availability and reliability in such a way that the users are satisfied and you are also satisfied, in terms of maintaining the system, in terms of cost, in terms of financial economics, right? Because it can take a lot of amount of money to make sure that a system is always up, right? Because you have to replicate it in many regions. You have to make sure that the disks are backed up, there's always something active, DR, etc., right? And you have to shoot for that 0 RPO and RTOs, which is very difficult to achieve. So the good thing that you can shoot for is a little bit less than 100%. That will make sure that you are innovating and you are balancing that cost versus availability parameter as well. So that's the general recommendation. Now one thing also, one thing can be like, when we say something right? It's an SLA, which is service level agreement to the customer, right? And this is just another service level agreement to customers, which is if you're running a GK cluster in a regional setting, the availability is the SLA is 99.95%. Now, if you commit this, right, then if you come below, there is something called financial credit. If you are not able to achieve that, then you have to pay something back to the customer if you breach that particular SLA, right? So you have to keep that as well in mind when you're designing your systems, because if you set a very high bar and you are not able to achieve that, then money can be going out of your pocket, right? So that's another thing to keep in mind. Now let's conclude things, right? So basically, if I have to sum everything up, uptime, it's like the system is operational, measured in duration, and as example is a server continuously running for a month. Availability is whether the service is accessible or not. It is percentage of uptime, and measured in percentage terms, where we say a website is accessible 99.9% of the time. Reliability means consistent performance without failure, right? Measured in MTBF, MTRR, error rates, right? So that's about this one. And you have to set realistic targets for availability and reliability, right? You can't just say, okay, I need 100% of availability all the time, right? So let's not be that demanding or naive, right? Whatever you want to call. But you will see some services claiming that they offer 100% of availability, but read the fine lines there. They say that, okay, the distinction is only when the downtime is larger than 5 minutes or 1 minute, right? So if suppose they face a downtime of 50 seconds and their SLA says they will consider a downtime only when the service is down for longer than 1 minute, right? So that 50-second will not be considered as a downtime, right? So read those things as well in when you're going into the the SLA of that particular cloud service or that particular cloud provider. So I hope you liked this video. If you did, do all those things, hit a like button, share this with your friends, and subscribe to this channel to see more amazing videos like this or cloud in general. Until then, you get to live, make the most out of it. Thank you.